Welcome back to the shop and to the channel. In the last video we got the table set on the saddle. We got the gib installed and adjusted after we shimmed it. Now we're ready to go ahead and get the rest of this top side wrapped up. The next thing I want to do is assemble this side of the table where the crank is at. So put a little oil on the lead screw before sliding on the bracket. I'm going to slide the bracket on here, but I'm not going to mount it just yet. I actually just want to get an idea of where it makes contact with the end of the table. Well, like I've done before on other parts of this project, I'm using some Permatex here on the end of the table. Since I will be using cutting oil, flood cutting oil on this, I want to make sure that as much of that oil goes back down into the sump instead of leaking out all of the sides of the brackets. And now I can go ahead and push the bracket all the way on and attach it with some Philister head screws. The table crank clutch is pinned to the table screw with the taper pin. You can see there are two holes there, which is evidence that this clutch was probably replaced at some point and a new hole had to be drilled through the table screw. This machine certainly has seen quite a bit of use in its life. Not sure who may have rebuilt this in the past, but it's definitely had some work done to it. Put a little oil here on that clutch so I can slide the dial on and then I can tighten down the set screw. Well, the dial isn't wanting to go on all the way. There must be a burr or something in here. Well, looking at this a little bit closer, I think maybe the taper pin isn't seated all the way. So grab a punch and see if I can't seat it down in there so it's flush. Well, that's fitting on there a lot nicer. It spins freely now. So I just need to line it up with the groove in the clutch before I put the set screw back in. Give it a little test drive here with the crank. The lead screw is moving freely because the other side's not connected yet. Once that's all buttoned up, this will stay in position. But we're not quite finished with this end of the table. I have a couple of parts that are missing that I'm going to have to make. This is a blow up of the diagram for the table crank from the parts manual. I know it's kind of hard to see. I'll try to point out what I'm going to be referring to. The point of this assembly is a safety thing. It makes it so you have to push the table crank in order to turn it. And that's so if that you're running the power feed on the table, that the crank is sitting there spinning waiting to take out an elbow or a kneecap. There are 4 parts that I'm missing from this diagram. They are parts numbered 30, 34, 35, and 36. Part number 30 is just a big screw that screws into the end of the table lead screw and holds the handle in place. Part 34 is a spring, simple enough, and 35 is just a simple 1/8 inch dowel rod. Part number 36 is called the crank sleeve, and it's a little more complicated than this terrible picture might make it seem. I was able to source the dowel pin easy enough from McMaster. The spring was a little bit of a challenge. I found it something that I think will work at Century Spring, and I think I can make that screw easy enough. It doesn't look overly difficult, but it was that sleeve that provided a challenge. But with some help from a friend on Facebook who has a K&T, he was able to give me some dimensions, and so I was able to come up with a drawing as to what this thing I think looks like. So not too complex, but it's not a simple sleeve. You can see it's got a couple of different radii in the ID, and then there's that slot in the side. Well, I've got this piece of scrap that I think will be just the right size. I don't have a lot of room to clamp it in the chuck. I'm not sure what this material was. I thought maybe 4140, but if you know what the orange and blue paint might have been or what this part might have been made from, leave a comment down below. I'm not really quite sure. Well, that sounds pretty terrible, and it looks pretty terrible. I think I might have a chip in this insert that I didn't notice when I started. But I also think that I am only clamping on this thing with maybe 1/4 of an inch inside the jaw, so I definitely need some tail support. That should improve the chatter. And while we're at it, we'll go ahead and swap the insert around to give me a new edge that's not chipped. After a quick rough turning, just using the micrometer here to see where I'm at to get an idea of how much further I've got to go. I have roughly 150 thousandths to take off of the diameter. With the OD turned to dimension, I can now concentrate on getting the ID board out. The smaller of the two IDs is about 1 inch 340 thousandths. We'll start with some reduced shank drill bits here to work up to about 1 inch. Well, I switched over to my boring bar, just touching off here, and we'll start boring this out to the final dimension. Without the tail support, I'm getting a lot of vibration. So I'm trying to see if I can dampen them with this piece of wood. Well, I chipped the insert on the boring bar and I don't have any spare inserts for it right now. So I switched over to this boring bar with a brazed on piece of carbide. These actually were a gift from Tom at Hilltop Machine Works. Well, instead of using telescoping snap gauges and a micrometer, I'm just going to use the table crank itself. It just needs to have some clearance in there. I don't want it too tight, but I don't want it too loose, and I think that's a perfect fit. Time to move on to bore the larger of the IDs. Now, this doesn't go all the way through, obviously, so I'm setting a dial indicator up here on my carriage so I'll know when I'm getting close and I can stop the power feed. We got a cutoff tool in the tool post now. We'll go ahead and cut this to length. I'll flip this over now with some copper soft jaws to go ahead and face it and chamfer the edges. With the lathe work finished, I've got it clamped in the vise on the mill so I can cut a 1/8 inch slot in one side of it. I'll quickly find the center here and then locate the bottom edge. I'm going to start by drilling a couple of 1/8 inch holes to give the end mill a little easier time to cut through this material. So first thing is I'll spot the start and end of the slot. Switching over to an 1/8 inch drill bit here, I'll drill those two spots that I previously marked. Switching over to a high-speed steel end mill, I'll plunge cut along the path between the two drilled holes, and then I'll come back and sweep down the edges to clean it up. I'll use a chamfer bit here just to make it look a little nicer. Well, that's it for the crank sleeve. This is complete. This will slide over the end of the crank handle, and that slot you can see here lines up with a hole in the handle where we'll place a dowel pin, and that restricts the length of travel that this sleeve can move. Well, one more part here that we need to fabricate is this big retaining screw here that you see in the drawing that holds the table crank onto the end of the lead screw. Well, with another piece of scrap chucked up in the lathe, we'll go ahead and turn down the diameter to the diameter of the screw head. Well, the screw is going to be threaded half 13. It's going to be 3/4 of an inch long. So we'll set a little guide here in some blue dicum and turn this down to a 1/2 of an inch diameter. Switch over to a chamfering tool to put a chamfer on the inside of the head, and then I'll put a nice generous lead-in chamfer for the die. I've got the lathe in back gear, and that just keeps the spindle from moving while I'm using the die and a little bit of anchor lube here to help with some lubrication. I always have challenges cutting off certain materials on this lathe, but the one thing that does seem to help the most is by putting the lathe in back gear, running it nice and slow, and using enough lubrication. Usually goes pretty smooth with that. Occasionally I'll still get some chatter, but this one seems to be running really nice. We'll turn this part around now so we can face off the top side and also give it a nice looking chamfer. Of course, it's always a challenge getting rid of the little pip left from a cutoff operation. The challenge is to turn it off, not try to face it off, because at that diameter your surface feet per minute is practically 0. Want to get the best finish I can on the top of this thing, so I'm going to engage the cross slide power feed here so it's moving in nice and slow with a decent feed rate, so I'll get a good good finish on this last pass. I think that looks nice, so we'll go ahead and put a nice generous chamfer on the top of this screw. Well, the last thing we need to do is cut the screw slot. So I have a collet holder with a 1/2" 5C collet on the bed of the bridge port. We'll get this clamped in. We'll start by finding the center of the screw head here by using this edge finder and the DRO's half function. I've got a 1/8" high-speed steel end mill in the spindle. We'll get it started up and we'll touch off on the top of the screw head. After touching off, I'll move off to the side and I'll bring the quill down about 50 thousandths of an inch. I have a stop at about 100 thousandths of an inch on the quill stop. So we'll cut this first pass about 50 thousandths deep. Drop the spindle down the rest of the way to the stop and traverse back to finish this cut to depth. I do want to make it a little wider though. I'll move the table over about 10 thousandths of an inch and take another pass. And we'll come back 10 thousandths on the other side of 0 to keep the slot centered. And just to dress this slot up a little bit, I've got a chamfering bit in the spindle. This probably isn't the right tool for this, but we'll run it down the center of that slot and put a soft chamfer on either side of it. Well, that should do it. Brush off these chips and we'll test the tool that I plan on using to tighten this. And it's got just enough play in it. I think that'll work out great. Well, okay, we can finally put this piece together. I picked up a couple of large springs here. One of them just about fits here. This is the one that fit better. We'll put that inside the sleeve and then we'll push in the crank. I do have to force that spring in there a little bit further, and then I will take this 1/8" dowel pin and go through the slot into the hole that's actually on the crank. And this is, like I mentioned before, what restricts the sleeve from sliding back and forth too far. Well, with that all assembled now, I can put it on the lead screw and test it out in the clutch. Now the screw will go on the end and hold this whole assembly onto the end of the lead screw. This video is getting long, longer than I like them to be, but I did want to show some of the details of what I was working on here. We'll wrap up the other side of the table and button up the coolant recovery in the next video. Don't forget to like the video, leave a comment, subscribe if you're not a subscriber, and a big thank you out there to all those that are subscribers or support the channel in other ways. It really helps me be able to do these things in the shop. Thanks for watching. We'll see you on the next one.